Hey guys, today we got stretches, shrinks, along with domain and range. Let's hit it. Okay, yesterday in class we did some transformations with moving graphs left and right, up and down. Today we're going to stretch them, shrink them, and also reflect them. So first of all, here's what you're looking for when you're looking for stretches and shrinks. This black graph right here is just our parent function, absolute value, V-shaped, goes through 1, 1, 2, 2, 3, 3, negative, same deal. When they put a 2 in the front like that, a 2 in the front, outside the absolute value, but in the front like that, it's a vertical stretch by 2. And if you look what happened, instead of going over 1, up 1, they went over 1, up 2, over 1, up 2, over 2, up 4. Everything's twice as steep as it was with that 2 not there. Okay, so number in the front, outside, is a vertical stretch. If it's bigger than 1. Now here's the case, what if it's less than 1? What if it's 1/2? Well, look at this one. The black graph is our standard parent graph of a parabola, quadratic. And again, the black graph, if you look at it, they went over 1, over 2, up 4, because they're squaring it. Well, if there's a 1/2 in the front, instead of it being a vertical stretch, it's going to be a vertical shrink. Because what happened here is they went over 1, up 1/2, over 2, up 2, instead of going up 4. So all the points vertically got cut in half. Okay, the y values did. So number in the front bigger than 1 is a vertical stretch. Number in the front less than 1 is a vertical shrink by that number. Okay, so let's try one here. Graph. This is a new thing too, but let's just go through. I don't know what I'm trying to say. It says graph and its parent function. So the parent function is absolute value. Absolute value, we just start at 0, 0, and go 1, up 1, over 1, up 1, over 1. So there's the parent right there. Now this is a good review from yesterday, plus one new thing today. And the new thing today is this minus sign on the outside. Anytime you have a negative in the front, on the outside, it's going to reflect across the x-axis, which means that V right there is going to be turned upside down. But we're going to do the transformations first like we did yesterday. Okay, the plus 5 inside means I'm going left 5, 3, 4, 5. The minus 3 outside means I'm going down 3, just like we did yesterday. So I'm going to start it there. And because there's a negative in the front, I'm going down, over 1, down 1, and over 1, down 1, making my V that way. So that V is actually down here. So the parent function's there. The transformed one is down there. Okay, now just describe. Okay, you don't have to graph these. We're just going to tell what's happening here. So the first one, I've got a negative in the front. So that means it reflects in the x-axis. Have a 1/4 in the front. That's a vertical shrink by 1/4. It really should say by a factor of 1/4, but that takes a long time. So we're going to say by 1/4. And lastly, it's got a plus 5. So we're going to say it shifts up 5. Okay, that's all of them. So look at number 9, same thing. I don't know why it's number 8. Number 9 just is. So let's just go through it. There's a 3 in the front, outside. That's a vertical stretch because it's bigger than 1. And how much bigger than 1? It's a vertical stretch by 3. There's a minus 5 inside, which means it's going to go shift right 5. I'm just going to put an arrow there. And I got a minus 1 on the outside, which means it's going to shift down 1 unit on the graph. Also, let's go through that. Remember, there's an x right there with no absolute value, no square. That's a linear function. I probably should have said at the beginning. And the second one, this is a review from yesterday. Second one has a square, which means it's a quadratic function. It didn't ask for that, but how about some extra credit? Okay, last slide. Identify the parent function, describe the transformations, and describe the domain and range. Okay, the parent function is the absolute value. So I can put here, it's absolute value. Describe the transformation. Well, it's going to shift. It's got 2 shifts. It's going to shift right 3. That's also going to shift, I messed that up just then. No, I didn't. And then it's going to shift up 2. Right 3, up 2. So technically, that parabola, that V shape, golly, I can't speak. Okay, so it's going to go right 3, up 2. Then I'm going to go over 1, up 1, over 1, up 1. So my V's up there. Okay, now here's the new thing for this slide. I need you to pick this up. Domain and range. All right, no big deal. Domain is the x-coordinates. It's how far your graph goes left and right. How far is our graph going left and right? Well, because that arrow's there and there, it's going left forever and right forever. So my domain is just going to be all real numbers. It's going left and right forever. You can also write it this way if you know what interval notation is. If you don't, we'll pick that up in class. The range, now, the domain is the x and how far your graph goes left and right, which means your range is your y. And also the y-axis goes up and down, so the range means how far does your graph go up and down. Now when you do range, you need to go down to up. You're always going least to greatest. So there's my bottom point right there. And where is it on the y? It's at 2. So my graph is going 2, and that's going up forever. So what I would say for range is I'll say y is greater than or equal to 2. Or you could also write it this way if you've done interval. Now you may not have done interval notation before, and if you haven't, we'll work on that later. But domain and range, one more time. Domain is the x coordinates, how far your graph goes left and right. Range are your y coordinates, which is how far your graph goes up and down. And we always go, on domain, we always go left to right, and on range, we always go down to up. All right, we'll work on that tomorrow too. Hope you got that, got some good notes. See you tomorrow.